Okay, let me give you another scenario. Let's say you are not given now this angle. In most cases, they are not given this angle. Maybe let me demonstrate another scenario. Let's say it's the same slope, but they give you in this particular height. They say the height is 10 meters. A, B. Now they give you the height, and you still have the same box here. Okay, in the car, whatever is happening, they say it's a car, when it's a trolley. The mass of the trolley is 50 kg. Now, as the trolley moves upwards, we find that the difference, we don't have the angle now. In the previous example, we had 30 degrees, but in this example, we have a height. Let's say from here to there, the distance, let's say it's 15 meters. My x is 15 meters from here to that one. Let's say my friction force, again, let's say my friction force is 20 Newton. Then, okay, my force applied is 70 Newton. That's the and the my VI is, let's say, 15 meters per second. Now we are given the height. So the point that I want to explain here is that we are not given now an angle, we are given a height. Then how do you do it? Here is the friction force, here is the VI, but let's say for infinite velocity VF is 0. Okay, VF is 0. Yeah, VF is 0. Let's say friction force is not given. Now let's say the friction, work done by the friction, that is work done by the what? Friction. Let's say friction is not given. Friction is not what? It's still. So let's say the unknown now is the friction. We don't know the friction. But this box is moving upwards. We don't know the friction. So we need to calculate work done by the friction as the object moving from A to what? To B. So obviously go to a formula, is work net. It's called to change in kinetic energy. But you ask yourself how many forces that are acting on this particular object. So friction is an unknown. They say calculate work done by the friction. Calculate work done by the what? By the friction. So we are calculating the work done by the friction. Right. How many forces acting? Okay, we know that force of gravity, the friction, and the force applied. So how do you express it? Work net, that is the work done, force applied, work done by the friction, work done now by the gravity. It's going to change in kinetic energy. But what is the work done by the force applied now? Oh, it's 70 delta x. What is my 15 times 15? Cos 0. Why say cos 0? It is because it is in the direction of motion. This is going up force 0. Plus, what is the work done by the friction? The work done by the friction, I do not know the work done by the friction. That's what I want to calculate. What is the work done now by the gravity? Now, the work done by the gravity, I know, I've said to you, work done by the force of gravity is mg sine theta. If there was an angle here, but in this particular case, there is no angle. So my work done by the is mg h delta mgh cos 180 degrees. You see the difference? I said first time work done by the force of gravity, work done by the force of gravity was mg sine theta if there was an angle here. But there is no angle, there is 10 meters. So what is my work done? They said it will be mg h cos 180. I think I want to emphasize this because I've got a height but I do not have an angle. So if you do not have an angle but you do have a height, you see fg is mg h cos 180 degrees. That is the point of emphasis. If it was an angle, it would be my force of gravity will be mg sine theta. Right. What is my force of gravity here? So my force of gravity, as I told you, what is my mass? My mass is 50 kg. What is my g is 9,8. What is my h is 10. Right. Delta. What is my? As I told you that the force of gravity is in the opposite direction times cos what? 180 degrees. So, what is my change in kinetic energy is half. What is my mass? mv half. My mass is 15 times what is the final velocity? We know it's going to be 0 minus half and v minus half 15. What is my I? Is 15 squared. So you can be able to get the work done by the friction by taking this thing, throwing to that side, multiplying, throwing to that side. You adding, you get what will get. You multiply, you pull that side, don't that side, and you are left with return. So let me repeat the scenario. I told you guys that you do have my initial velocity is 15 meters. We are told that it's going to stop there. This is my final velocity is going to be 0, and it's going in and right side, and the force that goes is about you pulling this thing. The force applied is 70 newtons. Then what I was trying to explain to you is that now we have a distance. In the last example we had a 30 degrees, but now that said mg sine theta only if there is an angle. But now we're not going to use this one. We're going to force of gravity is mg, work done by the force of gravity mg delta s cos 180 because there is what we call height. So work done by the force of gravity will be mg h cos 180 degrees. Then you can get now what is work done by the friction. You multiply, you take it to that side, you multiply, you take it to that side. So I think grade 12 student, you do have all these things. So another thing, if the object is coming down, let me explain. If the object is coming down, let me explain. I won't be able to calculate. Let me explain now. Yeah, the object now is coming down. There is a friction force. If the object is coming down, how many forces that are acting on this particular object? Let's say, for argument's sake, there is a work done by the gravity and work done by the what? By the friction, which is a change in what? In kinetic energy. My point of emphasis, I won't be doing the whole calculation, is that now the force of gravity is pulling the object and the object is coming down. So work done by the force of gravity will be F delta x cos 0 degrees. My F delta x cos 0 degrees if the object is coming down, because this object is in the direction of the force of gravity. So in other words, now for my force of gravity, when the object is going up, my cos will be 180, but if it's coming down, is in the direction of the force of gravity, my cos will be 0 degrees, and my friction will be F delta x cos 180 degrees is equal to changing what? In kinetic energy. My point of emphasis is that if the object is coming down, the force of gravity is F delta x cos 180 degrees. My F delta is cos 180 degrees. Then my friction is 180, but for force of gravity is cos 0 degrees. Why is like this? Because this is in the direction of the force of gravity. That's why we write cos 0 degrees. What is my F there? Is 15 times 9,8 times, let's say for an argument's sake, my distance from moving here was 10 meters as well. Let's say times 10 cos 0 degrees. Then, let's say x is unknown. X is what? X is unknown. If x is unknown, you simply write F delta x cos 180 degrees. Say friction force is 15 delta x minus 1. Maybe your kinetic energy, you do have some don't mv squared minus mu squared. So you can still calculate the value of x. Because if x is unknown, the distance is unknown, you substitute whatever you want to substitute, and your x now is unknown. You take your common factor x here. Say for instance, you do have those values mass, you do have this thing.